Q dash 3 division without remainders. So we'll take number 1 for example, and we'll say 452 divided by 8, okay? And those of you that were here on Friday, remember the first thing that we did, that we started doing, that we're going to do from here on out, was to do what? Hold on. Yeah, I'm going to put a decimal in this number in here. Where would that decimal come if I don't already see one? At the end. And once I put it there, I'm going to put it right up top. Now, if I keep everything in order and I put things where they're supposed to be, it should all work out on its own. So as we work our way from left to right, we just kind of go through and say, does 8 go into 4? No. 8 goes into 45. How many times? 5 times? And that's 40. 5 left. Drop the 2. How many times is 8 going to 52? Lucas? 6 is 48. 4 left. Now, I take this to completion by adding zeros afterwards, and 8 goes into 40 5 times. Okay? So we add this decimal, and we say, if I need it, I can add a 0 there. How many zeros can I add if I need them? As many as I need. I could keep going, and it wouldn't matter. If I need them, I can put them down. Turned out here, I only needed 1 to finish it. When is it finished? When down here is a 0, or we found out on Friday that sometimes you'll never get to 0 because there'll be a repeating decimal. Yeah.
If you, like, now we used to say you keep adding zeros and zeros, well, if you keep adding zeros, would that count as repeating?
Not for zeros. Good question, but, and besides, we would only keep track of the repeating part up here. Okay? So the zeros here, it's like, it's just like the knowledge of decimals, like 24, that's what it looks like. You don't have to put a decimal. But if I did, does that still mean 24? Yeah. And so does that, so does that, so does that. I could either have them or not. It doesn't change the value of the 24. And that's exactly what we do when we divide. Okay? So let's take a look at another one for those that were not here, because I'm hoping to get you some solid work time today so that you can just kind of get rolling with this. So let's try number 2. 679 divided by 4. First thing we're going to do, put a decimal there, put a decimal there. And then if we keep everything in order, we'll be just fine. 4 into 6, 1. So I put the 1 over that, 6. 2, 4 into 27. 6 is 24. 3 left. 4 into 39. 9. And that would be 36. Now I have 3 left. Well, that's when I start adding some zeros. So now does 4 go into 30? 7 times. 2 left, not done yet. Is 4 going to 20? 5 times. And I get my 20 and I get my 0. Okay? I want you to look at something that we did in the last 2 examples. Here, is where I would have had my remainder. Remainder would have been a 4 divided by 8. What's the relationship from that remainder 4 when dividing by 8? What is that equal to? Looks like a fraction, but we can put division problems and make them look like fractions. Half. This is half, right? That remainder portion was half. What do you notice about our decimal here? What is 0.5 equal to? Half. Okay, so we don't ignore remainders. We look at them, we use them, but we put actual meaning to them. The only other time you're going to start to see r anymore is if we use it as a variable, not as, some part of our division problem. Look at here. Our remainder, if we would have had one, would have been 3. But we were dividing by 4. 3/4. Did I miss something? Oh. I know this is fun. I know it was that fun. It's having a hoot back there. Real laugh riot. 3/4. 4 of these give you $1. 4 what? 4 quarters give you $1. How much do 3/4 give you? 75 cents. So again, the remainder means something, but it actually really makes sense when you put it into decimal form. Okay, you see that? Yeah. Now, we said we won't always be so lucky. Let's put that decimal in there. So we go 3 into 5, 3 into 21, 7. Now 3 into 2, after I subtracted, doesn't work, right? So what has to go here before I drop this 0? Need to put a 0 there. Now, how many times does 3 go into 20? There's an 18. 2 left. 20. Maddie, what's happening? What's happening here? I'm not getting a 0. It's going to keep going. Okay. So the 6 is going to keep going and going. Maybe when you've played with a calculator in the past, you've noticed that before. All of a sudden, you hit some buttons and you hit division. All of a sudden, the screen fills up with a bunch of the same number. And that's kind of what's going on here. But I have to write this some way as a final answer. I can't just write, well, how many 6s is okay? 4, 12, how many I have to write? So Tyler, I'm going to do what? Just one 6 is fine. Since 6 is the only digit that's repeating, that's the only one I need to put down. If I put that bar over the top, it means that it's going to keep going and going and going. Okay. Okay. Any questions? Any questions on this? Do you think you're okay? Second day we've done, right? Let's go to the homework side of your yellow sheet. We were just working through some problems on the practice side. The homework side, numbers 1 through 8. Numbers 1 through 8. she'll work on a separate sheet. I'm not even giving you the option of putting your work on the sheet because it's going to be too cramped. And you'll probably like to know that 1, 3, 6, and 7 are repeating. Okay? 1, 3, 6, and 7 are going to be repeating decimals for you. Okay? They're single digit. I can pretty much look at them and know which ones are going to work out. Once I know what the remainder is. Okay, so any questions there? Your work needs to be present. I would staple it to your sheet when you hand it in tomorrow morning into the folder that says math on it. Okay, now you've got 20 minutes of class time. You should easily be able to finish, okay? And then if you do finish, then you can read with the book that you brought for yourself today, or maybe there's other homework. Maybe you just had language arts, and maybe you had like spelling assigned or vocab or something assigned that you can do. Like, use the time wisely. Don't bother to ask to use the bathroom, okay, or drink. You'll survive.